Can you hear me okay? I'm not sure if this thing's picking me up. You guys can. How about you guys in the back? You're okay? Okay. All right. So I have good news and bad news. The bad news is I didn't have time to prepare. The good news is it means that I'm going to just give you demos. And the reason that works is because, let me go here, we actually finally released this. If you go to the homepage of ScalaTest.org, then it'll tell you that 3.0 final is actually out the door. It took us a year and a half. And so what I wanted to do was kind of just give you a little tour of what's in it. The main thing that happened was we decided to support Scala.js. And this represented a major change in requirements. It's an 8-year-old project, has a lot of users, has a lot of code. And we never foresaw that we would run on JavaScript. And so we had lots of things that unknowingly to us were actually tied to the JVM. So a great majority of the time was spent untangling disentangling ourselves from the JVM. And that's it's sort of the definition of a yak shave. To actually support Scala.js, we had to do things like invent an internationalization framework that works both on the JVM and Scala.js and JavaScript, which has nothing to do with testing, right? So I did want to do my first demo, which is to show you this running on Scala.js. This is a very simple tutorial project that we grabbed from the Scala.js folks. So if you look at build.sbt, what you have to do to get things to run on JavaScript is one more symbol in SBT, triple %. Obviously that means I want JVM and JavaScript, and I don't want to have to put this little underscore here. So that's what you got to do. And so this other stuff, that's it for ScalaTest. The other stuff is just some stuff that we use in the app. And the app that's being tested is called Tutorial App. It's a very simple little JavaScript application. And the test looks like any old ScalaTest test. It extends funspec, you import ScalaTest _, and then you have a describe and an it and an assert, and basically all the same stuff. And not all the same stuff. Some things just don't work on both. But anything that could work on JavaScript works on JavaScript, so that you can have test code that, one of the reasons, I think the main reason people use Scala.js is they already are using Scala on a server and they have a client that's in the browser, and they would like to use the same language so that the same people can work on both ends, and they can also share code. So this allows you to share tests, essentially, as part of that. So anyway, let's try it. I'll say SBT, and it's not very impressive actually, but it is actually running on Rhino. That is running that test on, let's see if it works. Not very impressive with the speed there, but that is actually running on Rhino. Rhino is a JavaScript engine that's on the JVM, and it is slow. So most people in practice don't, that's the default because it's there, but most people will actually run things on either Node or Phantom, which is much faster. So anyway, that is ScalaTest running on JavaScript. And what I would like to do is talk a little bit about some of these yak shave things. So here's my next slide, null argument exception. So I always think it's good to fail fast. So I occasionally would check like if I don't trust who's calling this method, I'll put checks for null at the top and throw null pointer exception. That's what you did in Java land for years and years and years, but there is no null pointer exception in JavaScript. And it's not because JavaScript is safer, they just call it something different. If something different gets thrown, right? So essentially one of the things that we had to do, and I'll show you what we did in 2.0. So I'm going to show you, this one is, this is the old stuff. Green is 2.2.6. And what I put in here is Scalactic 2.6 and ScalaTest 2.2.6. So if I just say console, there's something in Scalactic called requirements, which is, if I just say require, let's say val x equals -1, if I say require x is greater than 0, it throws requirement failed, and it's kind of unidiomatic to not put x was, I don't know, less than 0 or equal to 0 colon something like that, right? So that you get a better error message. That's sort of Scala's require. So in Scalactic, we have this thing called requirements. Oops, import org.scalactic _. We have this guy, and if you do the same thing, it actually gives you the same kind of error message you get with a test assertion in ScalaTest. So it kind of writes the error message for you, so it's it just saves you the trouble. But there was also one called require. There's one called require state, which through illegal state exception, and also will fill in an error message for you. And there was one called require non-null. And here I'll have to make some null things. See, there is use cases for null. There's one. I'm not. Okay, and val u colon string equals null. Let's say. You can say require non-null. If these are coming in one line of code, you can say st and u are not supposed to be null, and it will give you a null pointer exception that says the error message s and u are null. Right, so it's just one line of code saying these are the ones that I want to make sure aren't null, and you get null pointer exception, which was traditional on the JVM. So one of the things we had to do was in 3.0, so this is 3.0, let me show you the SBT file. So it's the same thing as the other one, but it's 3.0, right, instead of 2.2.6. So I'm going to start this guy, I'll do the same thing. And console, Scalactic, import requirements. So the other two things work the same, but this guy we had to change. And this is an example of DJVMification. Require, I have to do these val s colon string equals null, do the same thing, val t colon string equals not, val u colon string equals null. That's really easy to type null. It's kind of fun. Yes, require non-null stu. So this is a change in 3.0, and this is DJVMification. We had to actually invent something else called null argument exception that actually we made it extend illegal argument exception, which when you're checking preconditions kind of makes sense. So then we went through all of ScalaTest where we were throwing null pointer exception for precondition checks for ourselves in our own API and just replace it with this require non-null call. But that's something that's been in ScalaTest for a long time, but we had to make that change to like support JavaScript. So what I didn't want to do was make the JVM people suffer just because there's this new way to run this stuff that's on JavaScript. So hopefully that one doesn't bother JVM folks too much. You still get an unfortunate exception. Okay, so that's null argument exception. So one of the things that I do try to recommend people do is think whenever you put a require in there, I think it's good to fail fast. If something's supposed to be just a positive int, you should say require x is greater than 0 or whatever it is, right? So that it fails fast, and there's some, it's nice to have an error message either using requirements or you actually fill it in so that there's some forensic information people can look at to figure out what went wrong, right? But whenever you put in a require, I think it's good to think, well, can I actually get rid of that require by moving it into the type, right? So this came actually, we finished it like a year and a half ago, but we couldn't get it out the door because it was stuck in 3.0. So it's finally out the door as well, and it's a way to do that sort of thing where you have a restricted value type. So blue this is Scalactic. So I can say I want a posint, and if I put in 3, oops, I have to import it. So it's org Scalactic any vals. I get one. If I put in -3, you get a compiler error. So it actually doesn't compile if it's negative. And the way that works is with a macro that looks at compile time at what's being passed into posint, and if it's a literal, it just actually does the validation right there at compile time. And if it isn't a literal, let's make it an x equals -1. If I say posint of x, it gives you a compiler that says it can't prove that it's valid at compile time, so you can't use apply. So what this little bit of code is doing is calling the apply factory method, and that's what's giving you this compiler error message. And what it says is use the from posint.from factory method instead. So if you change apply to from, then what you'll get is an option. So you'll never get an exception out of this API. You could always call get on the option if you wanted to get an exception. That's what you're getting when you call get, possibly. And if it is positive, you'll get a sum. So if this, let's say val at y equals 1, then you get a sum. So then it really does represent this. It may or may not be valid, essentially. And what we put in version 1.0 is, I'm sorry, 3.0, I guess. Version 1.0 of this stuff. Actually, this is in Scalactic. Let's go there. There we go. Let's go to the anyvals package. So they're anyvals, meaning that basically if possible, it's just a bare int, like a raw primitive int. And only if it needs to box it does it box it in a posint. So it would tend to box it where it was in a regular int would be boxed as a Java-lang integer. That's where this would be boxed as an actual posint, so that it will be efficient. So we just have basically positive and positive with 0, so 0 or greater. And that's all we put for double float long and int to start with. And then there's this thing called compile time assertions, which is there to help you write your own. And as we discover what is generally useful for people, we'll add more. But I didn't want to just add everything I could pop into my head that would be possible. Like I didn't add one for negative because I've never in my life seen a use case for a negint, right? Even though it would be very easy to write, right? So over time we'll add more. One that I think would be possibly quite useful is a regular expression that actually checks a compile time that it's valid. That seems really like a no-brainer. So things like that we'll add, but there's going to be times when you need something that's not common. And so what compile time assertions is it's actually a way for you to to help you write a macro. All you have to do is you make the anyval, and then you make a macro that has an isValid method, and you just fill in the isValid method with whatever makes sense for whatever you're trying to validate on. And this works on anything for which there's a literal in code, right? So all the primitive types in string. And then you just add error messages. So those are just error messages that make sense. Either it's not provable because it's not a literal, or it's not valid. You come up with error messages for that, and then pretty much the rest is boilerplate. You just got to change odd int to whatever it is you're doing. So it's still a bit of code to write, and so if you have to sort of, when you write a require, think is it actually worth it to do something like this to get rid of that and put it in the type, to get rid of that potential for a runtime exception. And sometimes it won't be. But if it is, then hopefully this will help. So that's the idea of anyvals. And let's go back to my slide here. Okay. So that's anyvals. And this was also in 2.0. This was a nonempty list, but we made it an anyval. So a chain is at runtime, that's actually a Scala list, unless it needs to box it. So again, it's an anyval. So it's just a sort of a conceptual wrapper that ensures it's non-empty in the type. So if you try to make one empty, it won't do it. It just doesn't work. There's no way to make an empty one. And there's also a way to do this syntax. Instead of saying nil, you just say end, and you get a chain. So it's just a very low overhead way to say I want a non-empty list coming in. So you can put that in the type. And again, it's an anyval. Okay, so that's chain. And I said that was there in 2.0, but we just made it an anyval in 3.0. Okay, this is the second time I have good news and bad news. So there's something in Scalactic called OR, and in 2.0, I didn't know whether, I try to make things compatible. I think I actually have it in here. Yeah, so I try to make things compatible, and one of the things that I noticed I think I just forced myself to do that by saying oops. in either is that either has a left and a right, and left has two type parameters, and right has two type parameters. It remembers the opposite type parameter. The left remembers the right's type parameter, and right remembers the left type parameter, but it really isn't needed because it's covariant. So I did follow that just to be consistent, but instead of nothing, we just got rid of it, and it's now nothing. So I'll show you in 3.0 what you get. If you say good 3, it's just one type parameter. So this is a potentially breaking change, but most people don't actually put square brackets on these things like this. You know, they don't actually use it usually, so I think it won't break much code. So that is a change, and then bad is the same thing. Just has one type parameter, 3.0. And what this guy does, I can show you, oh, there's a lot of things with or in them. There we go. Essentially what it's for is either did not have attitude. There, in 2.12, either might have attitude, I think, which is that there was no map or flat map on either itself. So what you can do with or is write things like this, and what you can actually do this with any kind of type. So if I say val x colon map int comma string equals, let's make that a diff so it doesn't example. There we go. This, any type that has two type parameters, you can actually do an infix form. You can actually write it this way. I could say string or int map string. You just put it in between like that. It means the same thing. Anybody know that? Yeah, so it's not used very commonly, but what this type is or is int or, let's say it's int or string. That means it's kind of like either. It's going to be an int or it's going to be a string. But you can write it int or string, which reads as, it's kind of like a little DSL in the type name. It says this thing's going to return an int, or if something goes wrong, a string. That's how you read it. So this parse name method returns a string or an error message. An error message is just a type alias for string. And so I just say, if this thing is valid, I'm going to return a good trim string. Otherwise, I'm going to return this error message. And you wrap the error message in a bad. Whoops. And there we go. This guy returns an int or an error message. And then what you can do, basically, you know, a good wraps the good type and bad wraps the error type. And then what you can do is combine them, for example, with a for expression. So this does have map and flat map, and it's left biased. So parse person, oops, I need a person. I need a volunteer person. There it is. Okay. So this guy is just a for expression, and you, oh, that's the wrong example. That's either. Not that one, this one right here. Okay. There you go. So basically, you can just use a for expression like you can with option, and get, it'll give you a, you know, if both are valid, you'll get a good person back. Otherwise, you'll get the first error message, right? So that's what or does. And then you can also, there's something called every in Scala, which is a Scalactic, which is also like a nonempty sequence. You can't say every.empty. There is no such thing, but you can say every 1, 2, 3, like that. And what it has is two subtypes. It has one or many. So if there's just one thing in it, then you get that wrapped in a 1. So that's kind of like sum. Sum has just one thing in it. So a 1 has one thing in it, but there's, instead of sum and none, this is 1 and many. And the reason is so that, like if you have 1, you can't put 3 things in it, right? 1 just takes one thing. Oh, that's it. You know what that is? Anybody know what that is? Auto-tupling. So you can't put one thing in it. You know what? How I can demo this is go past 22 because, yeah. Let's see if I can get it to demo right here. I've probably screwed up my commas somewhere, but let's see if we can get it to work. Too many arguments, yes. So I proved that it's a 1. That's pretty bad. Okay, so anyway, you can only have one thing in it. So what you can then do is say, instead of having the error type be just something like a string or whatever error, you know, like a lot of times you may want to make a little error hierarchy and a case class hierarchy, and these are my errors. You say there's one of them, and that is in the type enforces that it'll only ever return one thing, one error message, for example, or one error instance. And instead of just saying bad string, you say bad one string here, and then let's put that one in there, see if this works. Parse age is int or one error message in this case. And now, if you import this accumulation trait, you can actually use this with good message, and this will accumulate errors. So, if you, you know, collect both of them and just toss them both into with good, it will actually give you a good person back if both were valid, or give you every error message. So that looks like this. So here's a good person right here, and this one where they're both invalid gives you all of the error messages, right? Yes. Huh?
Can you create a menu with 1?
I could say 132, and then add in, I guess. I don't know. Will that work?
To call the constructor of menu with 1 argument.
Oh. No. I see what you mean. There's more than 1. You meant that one. Yeah, you can't. And that's just done with, there's an argument, and then another one, and then a var args for that method, that apply method. Okay, so anyway, that's OR, and OR's actually been in there too, but it did have a pretty big, like potentially breaking change of losing that type parameter in good and bad, but it shouldn't affect much user code, I think, just because people don't usually write them in there. And so that's good news and bad news. So another thing that we added was a validating method for future and try. So that one, let me actually go to I'll just demo the future one. It works the same way with try. Essentially, with OR, there is a filter method. So if I say good3.filter, actually, let me go to future sugar, and I'll grab this method called isRound. All right, here's an isRound method. And what it does is just says if the thing is a multiple of 10. Oh shoot, I can't get off the screen there. I don't want that, I want this right there. Okay, see if I get it. If not, I'll fill it in. Number. Okay, so basically there's this thing called validation also in Scalactic, that there's 2 subtypes, pass and fail, and that's more like option, like with attitude. Usually option, none is kind of the thing you don't want, and some is the thing you do want because you want stuff. Here, the one with nothing in it is called pass, and that's what you want because it means it passed the test. So this is kind of like the type of a test. Whereas if it fails, then you want information about why it went wrong, or what happened, right? So fail actually takes an error type. And so what isRound does is it takes an int and it returns a validation of, in this case, the error type is string. Error message is a type alias for string. So if I have good hello dot, oh, this has got to be an int. Good 100 dot is a filter. I can say is 100 round, and it will basically give me back what I started with. It validated it, and I get the same thing back. If it's not round, let's make it 101, then it actually gives me, flips the OR to the bad type and gives me an error message. So that's one of the problems that people have had figuring out how to filter on something like either. What we did was we don't take a Boolean predicate for the function there. We actually take a function that returns an error value if it's bad, right? So what we did is we added a validating method to future and try that does the same kind of thing. So with try sugar, and I'll just show you future sugar, I'm going to import the members of future sugar, and I need to import Scala's future, and I need an execution context, and then I can show you, I forget what it's called, implicit, it's global. Okay, so now I can finally actually show you this. So I have is round. So if I take a future 100, then, you know, if you look at it, it's actually already succeeded. I can say round 100 equals fut 100 dot validating, and then it's kind of like filter on or, right? So you can actually validate a future, and I get a round 100 dot value. It actually survived because it is round, right? So if I did the same thing with 101 though, like this, then it should fail it, round 101. Okay, so this guy should be a failure, and it actually used that validation function that will actually give you something. But we had to wrap it in a throwable because future and try, that's their error type. So we made up something called validation failed exception that has a type in it. That you can have any kind of type in there. It's like a throwable container for the actual error type that you want. So that is new in 3.0, and there's one for try as well. So you can validate tries and you can validate futures and using this validation thing. Same as or. Okay, so that's that guy. All right, so another example of the yak shave was that when Scala, I'm going to have to do ScalaTest here. Let's do it over here. I need to say test : console. Essentially, when you when we have a test failure, I have some tests here. Oops, wait a minute. Let's run them. So I'm going to go and make one of these fail. Should have size 0. That's probably set spec. Yeah. Let's make it 1. That'll fail. One of the things that's in there is information about like the file name and the line number. This is actually 3.0. This is something new in 3.0, and that was done for Enzyme for Sam Halliday because in Emacs he needs the full path name to this file to make it like a one-click to the error message, to the actual line. This is the file name and the line number in that file, which has the assertion that failed that caused this test to fail, right? So in 2.0, the way we did that was and in 1.0 is we looked at the stack. So when an exception is thrown, all over ScalaTest you would see this little stack depth being passed in or being figured out by looking through the stack trace. It's either we kind of knew what it was or we inspected the stack to find the line of code that failed. So that in a throwable, if you throw, I don't know if I have to throw it or not, but if I actually, console, let's make a test : console. Let's see if I can get it here. New throwable. Let's print. Oops. Now I don't want to reverse search for a throwable. New throwable. Dot print stack trace. Let's see if I can get it to come out. Yeah. See, it actually shows you inside the JVM's stack trace. They'll tell you the line number and the file name where that came from, but there's no full path in the JVM stack trace. And it's not there if you have, you can actually optimize that out, but no one ever does that when they're compiling tests. So the test framework would always have that. So we would look through here to find it. And when sometimes we'd look through to find it, sometimes we just hard code it, say this is 3 down, is the one. So that's how we'd get this kind of thing where it's, it tells you where exactly where in your tests that this test failed. So the problem we had is that on Rhino, we were able to do the same thing. This is the JavaScript engine that runs on the JVM, but they were in different places. So the ones where we had hard-coded, which were a lot of them, we had to like, well, if it's JavaScript, then it's this hard-coded number, otherwise it's the other hard-coded number, which was ridiculously time-consuming and painful to do. But we did actually get that to work, so that was the way we did it originally. But the trouble is that most people don't use Rhino because it's too slow. It's like 10 times slower than Node, so it's just not practical to run your tests on it for any real project. And what they do to make, one of the things they do to make Node and Phantom faster is they take all your code and they put it in one big file, so it's all in one big file. And so now the information you got, like they would say that big file name, which doesn't exist in your project, and a line number like 13,000, because that's like where it was. So it just didn't work, right? So we were faced with the choice of like either taking out the feature, which was too painful for JVM people, because we don't want to punish JVM people because we decided to support JavaScript, right? Or not supporting on JavaScript, or just supporting on Rhino and not Node, and that's what we first did, but that was really lame because no one uses Rhino in practice. It doesn't really matter that it's supported, so that's really the same thing. So what we ended up doing, the other thing I was always worried about is compile time. I don't want to slow down the compile by too many implicit lookups, so I always try to be very careful about adding implicits. But we decided that we had no choice but to add an implicit position. And let me make sure it's test colon console here. Okay, so if you look at org.scalactic, I'm going to import this. There's something called source.position, and you can say here, and it'll actually give you a position that has a line name, a fully qualified, I'm sorry, a file name, a fully qualified file name. That's where you get the full path from, and of the line number, and that's done with a macro. So position.here is a macro that looks where it is, and it grabs it from the compiler at compile time and sticks it in there. That actually works on JavaScript, or I mean, to get that information this way would work on JavaScript with JVM because it happens at compile time, right? So what it looks like is essentially it actually shouldn't break anything. We just had to add an implicit position to most assertions and matcher expressions. So we did that, and now you get that same information on JavaScript in the JVM. But there's one other thing that we fixed that I want to demo here, and then I'll take questions. Sometimes people want to make assertions, so I'm going to say like betwixt, and I'll say low colon int, high colon int, and value. Sometimes you want to make helper assertions, where I might say assert value is greater than or equal to low, and value is less than or equal to high, right? Oops. Import org.scalatest.assertion. Okay, do it again. And boom. And I did not import assertions. Did I import org.scalatest? Let's do that. Okay, get everything in there. So basically your helper assertion might look like this guy. And that, let's see if that works. So I can say assert betwixt 1, 2, let's say 1 to 10, and if I say 3, that works. But if I say 13, that's unlucky because I get a test failed exception. So if I actually capture that, let me show you this. I'll do it paste val x equals, and I'll do it this time. Oh, I need to say intercept. Exception. Boom. All right, so I'm going to actually intercept and capture that one, and I'm going to do the same thing, but I'll call it something else. EY, and do it again. Okay. Import org.scalatest.exceptions.testFailed exception. And do that again. right there. Voila. Okay, so if you look at ex.failed code failed. Oh, I've hung it. I may have to use words. Well, I will tell you in words because it just crashed. That's a bummer. Yeah, it did. There we go. If I say ex.failed code, there we go, file line number, and ey.failed code line number. It kind of looks this silly because if I go to line number, so it both says 20, and the reason is because what you get is you get the actual position inside where this happens, because this is the guy that figures out what the position is, right? So you get the line number there, and what you really want is the line number here and here where it's called, right? That's what you want. So what you can do in 3.0 now is when you define your helper assertion, you actually take an implicit source position. I forgot to give it the name here. You take one there, and it will be computed there. There we go. And then go up and give my assert on the inside. And then the one on the inside will pick that one up. It won't be computed again. So you actually get the good stack depth. So now if I can go back and do EX and EY, we should see two different ones. Okay. So ex.failed code line number. That one's 21, and EY is hopefully 22. Yay! So that's it. So that's a new feature in 3.0. So there's actually a lot more, and I'm going to stop now to take questions. Yeah. Anybody have a question?
Could you show real examples of real tests?
Yep. That looks the same, actually. So one of the things that was the main requirement of 3.0 was all the old stuff continues to work.
Yeah, but maybe something more complicated.
More what?
More complicated.
More complicated? Oh, you like complexity? Well, you came to the right place. Hang on a second. I'll show you something complicated. No, that's okay. Yeah, our tests are crazy. So, I don't know. Yeah, how about selenium tests? Web browser spec. So essentially, yeah, I don't know what to look for, but actually it's just like larger, yeah, I'm not sure what you're after. Yeah, but yeah, if you want to see massive amounts of tests, go look at ScalaTest itself. We have ridiculous numbers of tests that, this is just one test class, testing the Selenium DSL. I wouldn't call it complicated, just ridiculously huge. Does anybody else have a question? We'll keep answering this one for a while. Yes?
The future sugar, once you validate it and failed, you got back an option of a try. That wasn't an option.
Future sugar, it went back. It stays as a future. I think.
Yeah, probably, but there was some result where it was like an option of a try, and I was wondering why it was just not a try.
Oh, that was when I said .value on the future, and that just means that it is finished. If it's a sum and it hasn't completed, if it's a none, the future itself has not completed, it'll give you a none when you say .value. It's like a poll, like you're just polling the future to see if it's finished, and if it's not, it says none. That's what the option was.
It's a trap.
Fair enough.
Anybody else? Yes.
I have a question about the OR abstraction. It seems that, I mean, at the beginning there was the either class, and then in Scala 10 we had the try.
Yep.
But then it's not even enough, and Scala Z has its own
Right.
flavor of either.
And that wasn't enough for me.
But
Right.
all the improvements make sense. do you know if there is any fundamental reason that the original either is not?
Yeah, I think it's being retrofitted. So my perception was, and maybe somebody knows, that it got actually, there was a pull request to add map and flat map to write bias either in the standard library, and that is actually going to go into 2.12. Does anybody know that that's true?
That is correct.
Yeah, it's in, so.
If you want it to 2.11, it's relatively easy to do it implicitly. So like, you can put an implicit in your file that will allow you to have a write bias either that's source and binary compatible with 2.11 and 2.12.
Yeah.
It's like, we don't need OR anymore, Bill. You can just...
Oh, but OR has some, I'm going to continue this. So OR has some, there we go, we're finished now. And my time's up. No. Is my time up? Okay. All right, I'll go backwards. So is there any other questions? Yeah, okay. If I'm just going to tell you what I didn't cover so you know what else is in there. These guys didn't exist before in 2.0, and this is, you could say one element, one of, in ScalaTest matchers, and you could say 1, 2, 3, it's a var args. But if you had a list with 1, 2, and 3 in it, you couldn't use it. So now you can. So that's one thing in ScalaTest. There is a way to prettify toStrings on error messages. So if you ever like testing with Java types that have ugly toStrings, you can make them better in your error messages. And then the big one that I've talked about a lot, which is why I put it last year because I figured I wouldn't have time, is async testing. So if you want to hear about async testing, that was something that was required by JavaScript. It also works on the JVM. Then I would look up one of my talks that from earlier this year where I talk about that. But that's a type of test where you give a future back to ScalaTest. And I will show you an example. It's not complicated. Oh, I should have said push D. This is called Hidden Gems, Demos 3.3.0. Yeah, it's right here. Oh, here's one. So essentially, if you have a future in hand, this future sum is a future int, you can just map an assertion onto that future and return immediately that future to ScalaTest, and the test will complete when that future completes. So that's what async testing is in a nutshell. All right, well, thank you very much.